Well, today we're going to look at our third method for solving a system of equations. So we've got our system of equations. We have two equations in the same problem, the blue one and the red one. Notice it's got an x and a y. So what does that tell us? That the solution to this equation is going to require two numbers, a pair of numbers, and there's going to be lots of pairs. In fact, infinite pairs of numbers. So I could solve this equation by graphing it and showing all the solutions on the graph. So I could do that by turning it into y equals mx plus b. So I want to get the y alone. I'll move the negative 5x to the other side by eliminating it, by adding 5x, y equals positive 5x minus 7. Remember, these aren't like terms, so you can't combine them or eliminate them. All you can do is put them side by side. And this one's positive, this one's negative. So this is our slope, this is our y-intercept. I can graph this. Let's draw an xy axis. So I know that the y-intercept is at negative 7. Let's go down to negative 7. 1, 2, 3, 4, 5, 6, 7. And my slope says go up 5, right 1. Up 5, right 1. So 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. You get something like this. And this line represents all the solutions to the blue equation. Let's do the same thing with the red equation. I want to get y alone, so I'll add 3x to both sides. That leaves me with a negative 2y. You have to hang on to that minus sign. It turns into a negative sign. Equals positive 3x minus 12. Y is still not alone. I need to divide by negative 2. That gives me y equals negative 3 halves x. And remember, we can leave the negative sign on the denominator or we can put it on the numerator, but you can't put it on both. So it's one or the other. And then negative 12 divided by negative 2 is positive 6. So what I want to do then is graph the red equation onto the same graph. So the y-intercept is at 6. 1, 2, 3, 4, 5, 6. And my slope tells me to go up 3, left 2, because it's negative 2. So up 3, left 2 is about here. Or I can move the negative sign to the numerator, because it still makes it a negative fraction. And I can go down 3, right 2. So down 1, 2, 3, right 2. And there's my line there. So this red line represents all the solutions to this equation. The blue line represents all the solutions to this equation, but look where they intercept, right here. That is the solution to the system of equations. It's the one point that will solve both equations. So we just solved this by graphing, and the last lesson we solved by substitution. So I'm going to go back and I'm going to redo this problem with substitution, and then I'll do elimination. So you can see all three methods at once. Notice the problem with graphing is that if you don't have nice clean graph paper, it's hard to see where this point really is. And if it was another problem, the solution may be way off the graph and it wouldn't have shown up on our graph. So even though I like graphing because you can see everything with your eyes, it's all drawn out, you have a nice picture, substitution and elimination are probably better techniques for actually getting you the right answer. So let me get my eraser here, and I'm going to erase this work here. And I'm going to take the blue equation, and since it's solved for y, I can take this and substitute it in for this y. Alright, so now we have negative 3x minus 2, and instead of y, I can replace y with the information from the other line. So 5x minus 7 equals negative 12. Alright, so I need to distribute. Negative 3x, negative 2 times 5 is negative 10x, negative 2 times negative 7 is positive 14, equals negative 12. And remember, the great thing about this is now I just have an equation with just x's in it. So negative 3 and negative 10x are like terms. That's negative 13x. I'm going to get rid of the 14. So I'll subtract 14 from both sides. That gives me negative 13x. That cancels. Equals negative 26. A negative and a negative makes a bigger negative. Divide by negative 13. X equals a negative divided by a negative is a positive. So x equals 2. And then I can take that and plug it back in here. 5 times 2 is 10. 10 minus 7 is 3. So I get y equals 3. Now this looks like 2 comma 3. So I think we got the right answer here and here. So the two methods so far we've done, graphing and substitution, got us the same answer. Okay, now let's look at the third and final way to solve a system. I'm going to go ahead and erase the graph too. Okay, so remember the elimination method, we put the two equations underneath each other. And we add the two equations together. And hopefully one of the variables will eliminate. Well, it doesn't look like that's going to happen because none of the coefficients, the number in front of the variable, none of them match. So I'm going to have to change one of my equations so that I get a match. So if I multiply this equation times 2, then I'll have 2 times y is 2y, and that'll cancel with the negative 2y. So that's what I'm going to do. Let me erase this so I have more room. Let's distribute. Go back to blue. 2 times negative 5 is negative 10x. 2 times y is 2y. 2 times negative 7 is negative 14. Okay. Rewrite the second equation underneath. Negative 3x minus 2y equals negative 12. Now I've got a match, and they're opposite signs. One's positive, one's negative. So when I add them together, they'll cancel. So I'm going to add these two equations together. Negative 10x and negative 3x is negative 13x. 2y and negative 2y cancels. Negative 14 and negative 12 equals negative 26. Does this equation look familiar? It should, because like 5 minutes ago when we were solving by substitution, we ended up with the same equation. So I just divide by negative 13. X equals positive 2. Great, that's what we wanted. And then how do I get y? I can plug the 2 back into either one of these equations and solve. So I'll do the blue equation. negative 5x plus, well, x is now 2, so I can replace the x with 2, plus y equals negative 7, negative 10 plus y equals negative 7, add 10 to both sides, y equals 3. Alright, so you can see all three methods give us the same answer. That has to happen. If they gave us different answers, they wouldn't be valid methods. We couldn't use each one. So you have three different ways to solve systems of equations now.